The electromagnetic spectrum encompasses all the types of electromagnetic radiation, all the types. And what do I mean by the types? Types means they're different by their wavelengths and ultimately what their frequency. So if you look here, down here, you'll see the wavelength, and on the top you'll see the frequency. And we see that the wavelength is longer here, means you have a shorter frequency. Frequency is quite large here. You look at it, it's 10 to the negative 1, for example. And as you move to the left, it becomes 10 to the negative 12. Very small on the picometer. Here you have 10 to the 10th. As you move to the left, it becomes 10 to the 20. So you see the frequency is increasing while wavelength is decreasing. So of course, we get the different types of radiations here. So let's begin quickly. Well, we begin that when we have a large wavelength right here, we begin with something called, we begin with radar and radio waves. Radar and radio waves. Now we know that we know where radar and radio waves are used in. Yes, in communication. And let's say you have the AM radio, the FM radio, broadcast, wireless radio, all of that. Okay, what comes next? Well, you have microwaves. So notice that the wavelength is getting shorter and the frequency is increasing. So it's becoming more energetic. As you move here, you notice now you have microwave. All of your cell phone, smartphone signals are in microwave. So it's cell phone. Radar for weather, data. Wireless data, like when you have a router at home, that's a microwave. Microwave oven too. That's all here. Okay. Notice again what is happening. What is happening is the wavelength is getting smaller while the frequency is getting larger. Again, you have small wavelengths means you can fit in more of them and the frequency increases. Very well. What comes next? Well, we have infrared. Infrared is nothing but heat radiation. You know, your body right now is emitting infrared. And this is used in night vision goggles. Not sure if you know what those are. In the remote control, the signal is in infrared. Then so if you get here, if you look far and near infrared, you'll see that you have now the only region we can see. That's called the visible. The word visible means that's the only one we can see. And it begins with red right here, or maybe a little bit darker, and then it moves all the way to violet, a little bit darker as well there. So the word infra means inferior, and becomes before red, it means it's lower than red in energy. That's why it's called infrared. And again, look at red here. It has a larger wavelength. As you move to the ultraviolet, it gets smaller. Make sure you know the visible region range. And that range is between that's between 350 to 800 nanometers. We can say this is violet, just to make it simpler, and this is red. Red is lower in energy, violet is more in energy. Next, ultraviolet, because it comes after violet, so it has more energy than violet. And we know where ultraviolet is used in. It's used to disinfect, for example, medical equipment and dental curing. See that, they do that when you have any dental work. And then what comes after that, and of course it's harmful for our skin, comes after that is X-ray. Also in medical procedures, like you need an X-ray for your bones and your lungs, whatever it is. And then finally, it ends with gamma rays, which are the most energetic. Very, very high doses of those are dangerous to you. What are they used in? They're used in PET scans. I don't know if you, or PET scan, or the usual called PET scan. Or those are cosmic rays, which are, they can be very harmful to living organisms. Very well. So let's continue. Quantum theory. Quantum theory begins with Max Planck. Max Planck in the 1900 introduced the idea of the quantum. And the word quantum, after you watch that video, okay, it means nothing fancy. I mean, I'm going to jump here and say, here's what it means. It's a discrete amount of energy. That's all it means. So he said an oscillating electron can have only discrete or specific amounts of energy. The word specific amount of energy. Okay, quantum comes from quanta, which comes from quantity, amount, but it's a specific amount. Planck said that the amount of energy depends on its frequency, as we said, and he took the first step toward quantum mechanics, and his hypothesis correctly accounted for the observed intensity with respect to the frequency squared. A little bit more advanced, but what we want to know about the quantity here is that, imagine, we want to move away from just an arbitrary amount or range and just move to something that is, again, very specific. So imagine you have a ketchup here. Well, a ketchup can come in a packet, or it can come in a bottle. Granted that a bottle has a specific amount of ketchup in it, but that's not the point. The point is, if you put some ketchup on your, let's say you have some French fries, and you use 3 packets, then you used exactly 3 packets. That's a specific amount of energy. But if you grabbed a bottle and just, said, okay, here, I'm just going to add some to my French fries, and, well, you did add some amount, but it's not as measured as precisely as a packet, okay? So you actually added some kind of an unknown amount. So you can say it's unknown, or I would say a better word would be unspecific, if that's a word. So again, you added an arbitrary amount. So let's look at another analogy here. We need to move away from what we call continuous energy and move to something called quantized energy. So if you look at this person here, if you look here, this person is climbing the stairs. She or he or the person, on every step, they have a specific amount of potential energy. You know that from the last video, as in thermochemistry, you know that with height, you have more potential energy. So if you think about it here, stepping on this one has a specific amount of energy. Stepping on the second step, specific amount of energy. The third and the fourth, all are specific amounts of energy, potential energy. Or even asking, which step are you on? I'm on the second one. I'm on the third one. While with someone, goes up a ramp, this is really unspecific. It is, we couldn't know because, again, the height is kind of like a range here. It's continuous. So this is specific and this is continuous. So this is where classical mechanics was like, doesn't work anymore. So again, we want to move, this is what we want to adopt. This from now on, and kind of ignore this only for maybe light in general, but not